So in this section, again, we discussed the mean value theorem. We have not given you any formal definition of continuity, and that's not part of the pre-calculus course, but we are kind of understanding how continuity work for polynomials. There's no breaks, there's no holes, there's no going to infinity, that sort of thing. And polynomials are continuous functions, it turns out. And mean value theorem is a theorem that works on continuous functions. So if f is continuous on an interval a and b, on a closed interval a and b, and then for any r between f of a and f of b not including, there exists c between a and b not including, such that f of this c is equal to r. So let's start with one pictorial example. So here is the function, graph of the function going. Then we have interval a and b right here. And function is continuous over a and b. And even though this, let's smooth it out a little bit. And then what happens in here is that I'm saying, so value of f of a is right here, value of f of b right there, and if I in whatever value I choose between these two, let's say r, then I can draw this horizontal line, and since the continuity is there, it's going to cross the graph of the function, and then from there I can find an x value for that point. That would be the c point. So, and notice that c and r is on the graph of the function, so f of c is equal to r. The next thing that comes in mind is this C unique or not? And then let's give you another example. So if I have an interval going from, let's say, if I choose my A, B to go through this section, so BB here, then f of b is going to be about here, and then this time around, if I find a value between f of a and f of b, so a y value, and draw a horizontal line to find all x values that correspond to that y value, I get 3 different values. So this c is r, this d, and e. F of b equal to r, and f of e equal to r. So I can get multiple values for that. But in what the theorem is telling you is just one value would work. You will have at least a value of x if the function is continuous. It doesn't work for values of r above or below, even though in here I know that whatever value of this value is, I still have an x value that matches between a and b, but you're not using the mean value theorem for value of r outside the interval, open interval f of a and f of b. So that's this. How do we use it in pre-calculus? In pre-calculus, one of the major issues that we resolve using the mean value theorem is when you're finding the zero of the function, and then you try to find the inequality of that function bigger than 0 or less than 0. So for example, if I'm solving, let's say x minus 1 times x minus 2 times x minus 3 bigger than 0, then as we learn, let's put this to power 2. As we learn, I'm supposed to put all the zeros of that on the number line. 1, this one gives me 2, this one gives me 3. Then I can find a value over here, a testing point in here, to see, and let's say I plug in 0. If I plug in 0, I get negative 1 times negative 2 to power 2, which is a positive value, times a negative value here. So the entire thing would be a positive value. So if I plug in 0, test 0, I get a positive value. And this mean value theorem assures, it actually guarantees for us that everything from negative infinity to 1, which is the first 0 of the function, is going to be, the y value for that would be positive. That's how it works. Because if we had any change of sign over here, by mean value theorem, if f of a and f of b have different signs, r equal to 0 will give you a root in between. Therefore, that's one of the ways that we use it. And so between 1 and 2, I know that there is no root, so I can guarantee, and I know the sign is changing, so it goes to a negative, or I can use a test point. At 2, I know the sign does not change, and between 2 and 3, by mean value theorem, it doesn't change. And then at x minus, at 3, it's going to change sign, and I know from 3 on it's going to be positive. Again, how do we use it? How do we use mean value theorem in finding the inequalities? Mean value theorem says if f of a and f of b are of different signs, in this case, let's say, if we say that within an interval sign changes, then r equal to 0 has a solution between a and b. So if I find a and b in this area, as such that, let's say, f of a is less than 0 and f of b is bigger than 0, then I will have a 0 over here, which is a contradictory result. So anytime that I have an interval without 0, the signs cannot change. And that's how we use the mean value theorem. The major usage of the mean value theorem in pre-calculus is that one.